Welcome everyone. This video is on percent composition, which is a way of evaluating samples to see how much of an element is present. So percent composition is the percentage by mass of each element in a compound. And the way we can calculate that is by taking the mass of the element by the total mass and then multiplying by 100. So when we are calculating percent composition, the first thing that we usually want to do is define the molar mass of the compound. We're then going to determine the mass of each element in that compound. So if, for example, you have 2 carbon atoms, you're going to take 2 times the mass of carbon. If you have 1 hydrogen, it's just the mass of hydrogen. Then you're going to divide the mass of the element by the molar mass of the compound. And then finally, multiply your answer by 100%. The one really important thing I want to point out with percent composition, you can always check your work by adding up the percent composition of all the elements in a compound. If you did everything right, the sum should equal 100%. Let's go ahead and work through some different examples. Okay, so let's work through some of these example problems. So the first one, we want to find the percent composition of copper in Cu2S. Well, the first thing we need to do is find the molar mass of our Cu2S. Okay, so if we look on the periodic table, okay, so let's try some example problems with percent composition. So the first one, we want to find the percent composition of copper in Cu2S. So the first thing we need to do is find the molar mass of our copper sulfide. So I'm going to start by listing out the elements I have, which is copper and sulfur. And then I'm going to list the number of each. So I have 2 copper and 1 sulfur. Okay. I'm going to look at my periodic table to find their molar masses. So copper is 63.55. And when I multiply that by 2, I get 127.1. And then sulfur is 32.07. I just have one of those. So once I have those 2 values, I'm going to go ahead and add them up. And that gives me a molar mass of 159.17 grams per mole for my Cu2S. So now what I want to go ahead and do is I want to take the mass of my copper in my sample and divide it by the total mass and then multiply that by 100. So the mass of my copper in my sample is just 127 because I have 2 copper atoms per copper sulfide. So to find the percent comp of the copper, I'm going to take 127.1 and divide that by the molar mass, which is 159.17. And then I'm going to multiply that by 100. So 127.1 divided by 159.17. And then I'm going to multiply that by 100. And for these, I'm just going to go ahead and round to the tenths place. So I end up with 79.9% copper. Okay. So for my next example, I want to go ahead and find the percent sulfur in my copper sulfide. Well, I already have the molar mass from before, so now I just need to take the mass of my sulfur and divide that by the molar mass. So this time it's going to be the 32.07, and we're still going to use the same molar mass as before, so 159.17, and then multiply that by 100. So that gives me an answer of 20.1% sulfur. So the really nice thing about percent composition is I can always check my answer. And the way I do that is I add up the percent compositions of all of the elements in the compound and they should equal the total amount, which is 100%. So the percent copper plus the percent sulfur needs to equal 100. So if I go ahead and actually plug in my numbers, I have 79.9% for my copper plus 20.1% for my sulfur, which just so happens to add up to 100% exactly. So I got the right answers for those two. Okay, let's go ahead and try another example. So this time we want to find the percent composition of a sample that has 28 grams iron and 8.0 grams oxygen. Well, this one's going to be a little bit different since I don't have a chemical formula. I cannot figure out the molar mass, but I still know the mass of each of my elements and I can figure out the total mass. So this is going to be a little bit different, but not too hard. So the total mass is going to be equal to 28 plus 8. So if I go ahead and add that together, that gives me a total mass of 36.0 grams. Okay, now technically if I'm thinking about my sig figs, this one has 2 and it's getting rounded to the ones place. This one's getting rounded to the tenths place. So if I go ahead and round that appropriately since I'm adding, the answer is just going to be 36 grams for the total mass. Okay, so let's go ahead. We want to find the percent composition. Since it's not specifying a specific element, I need to go ahead and do it for both iron and oxygen. So my percent iron is going to be equal to 28 divided by 36 times 100, which is equal to 77.8. And my percent oxygen is equal to 8.0 divided by 36 times 100, which gives me 22.2. Okay, if I go ahead and add those up and check, 77.8 plus 22.2 is equal to 100%. So again, I know that I have got the right answer there. Okay, so our final example of what you might see for a percent composition problem. How many grams of copper are in a 38.0 gram sample of Cu2S? Well, this one is a little tricky unless you already know the percent composition of copper in Cu2S, which we just happen to know from before, that the percent copper is equal to 79.9%. So I'm going to actually change that back into the decimal form. So it's going to be 0.799. And then all I have to do is I'm going to take the total mass times that percentage, and that will give me the mass of the copper. So I'm going to take 38.0, going to multiply it times that percentage as a decimal, so 0.799. Which gives me a mass of 30.362 grams. So now I need to think about sig figs. I have 3 sig figs here, so that's what I'm going to round to. So this is going to give me 30.4 grams of copper. Okay, so I hope that helps. If you have any questions, please go ahead and let me know. See you later. Bye.